Welcome back to the logic tutorial for simulation and prototyping. This is where we left off, where we've created a beam that has multiple columns, and this is updated based on just one simple line that we're giving it. If you remember from the first portion of this tutorial, we created a line from along the top edge. What we're going to do is use this line now to subdivide, to start to look at placing a series of rafters. And the second part of this, in this tutorial, what I want to do is to use our same type of logic, but now lay in a set of dimensional lumber. And the reason why I wanted to do this is that it deviates from standard kind of parametric practice that would just say the length over the depth has a ratio, and as all of the lengths change, all of the depth varies accordingly. That's not true when it comes to dimensional components. And so we're going to imagine this as a simple wood structure where these will be based on the specific sizes of lumber. And so there's a kind of rule that we have as it relates to this, and I want to work with you to build this up. And maybe before we go too far, what I'd like to do is, the definition got us to a certain extent. What I want to do is just add a couple more components to the first definition, because what I'd like to have is multiple. I'd like to have more than two girders. And before I copy it, I want to add a couple of elements so that when we copy this, we can copy those things. So what I'd like to do is again, I'm going to use that term of a global parameter. I want to set a global parameter for the spacing of the rafters. And so to follow the convention that I've been using, I'm going to create a panel way over here on the left. And this will be, let's call it, so we'll right click and change the name for panel. Let's call this rafter spacing. Let's set this to be 24 inches. And again, we can change any of these things, later. We might actually want to have them spaced a little closer just for what will look good for our model that we're working on. So we've got that. So let's add two more things to what we have here. And the first, which we could duplicate, or, well, let's just duplicate it because it's easy. I'm going to work on our top. I'm actually going to delete our second set of definitions. And I'm going to ungroup these by right-clicking and ungroup, just because I want to add a couple more things to it. So we have this move. Let's get the length of this. And we already have the length elsewhere, but let's just have it here so it's close. There's nothing that, it's not going to be a performance impact as it relates to that. And this should be the length of the first line that we had, but now we have it close and we can do that. And what I'd like to do is divide. So we'll use a division. I'd like to divide this length by that new global parameter that we just added, the rafter spacing. And then we can use a hidden wire for that. And let's check our panel, or we'll add a panel for this result. So what we end up with is the length of the top of that girder edge divided by the number of, or divided by the maximum width of our rafter spacing, and then that gives us a number. And what we can do is turn this into an integer, or we could fix This is another way to do what we did earlier by creating an integer container. We basically just did what we did earlier with our expression with that fix formula. So now this is telling us that if we're using that global parameter of the rafter spacing, this results in 27 divisions. And so this is good for us to then stop with this or use this to group these together. And we have that. And what I'd like to do now is to copy this whole thing. And I'm going to, again, pull that last group that we made together there, because what we want to do is to now compare these two. And let's see, do we have a second line? We can set that. And so there's the second line that we had. Okay, so now using these two, what we'd like to compare, let's even zoom in a bit, we can see that one of them has 23 divisions, the other one has 27 divisions. And I don't want to get too into construction logics here, but for what we're going to do, rather than keep the spacing consistent in terms of 24 inches or 16 inches and have all those parallel, you would want to do that if you were working with plywood sheets, and if these weren't parallel, you'd end up cutting every single sheet, and there would be other implications for this. Let's put that aside for a second, just because I want our structural model to just look pretty clean and simple. And so as we divide each length, we see that there's a different amount. If we were to simply divide one of them by 27, the other one by 23, we would have to deal with those 4 extra divisions and what would happen with that, right? These could all run parallel at 24 inches, but as we got to the end, then they'd space out and they would come to the last point here. I didn't think that that looked very good. And so what I'd like to use is to decide one or the other. And so let's use the smaller than, which we've already used before. And we'll take the first number and the second number, and we'll decide which one is smaller. And let's use the stream filter. And we can plug both of these in. And so whichever one is smaller will result in, and let's see if this works, smaller number or the larger number. And let's see what comes out. And I thought this was the case. And so this was a little weird. And here's what we have to do. We actually end up flipping these. It would make sense that this plugs in here and this plugs in here, but the smaller of the two is not 27. And so basically what we're saying is 27 smaller than 23? The answer is false, which then means that it's giving us the 0 stream gate. And so we want to flip these two and actually I think it's a better practice not to pull from the panel, but instead to pull from the integer. And so now we can see the smaller of the two is 23. If we change our line of the second smaller version, it's 25, 26, 27, and now 30. So because this one is 30, now it tells us that the smaller of the two dimensions is 27. That's fine. Thought this did something maybe a little weird. 28, 27 or 26. So that's okay. That's looking good. there's a big jump with this to a big cantilever. But that's okay. Let's have these be a little bit different. But we can see as we draw these lines, now we've got a really dynamic condition that's driven by, it doesn't matter what we draw, but through the definition, we're able to control these things. And so the smaller of these two is 24. So that's good. Let's then pull from this an integer. And with that integer, let's divide each of the curves. And so now we kind of worked with these two separately. We brought them together here, and then we'll split them back again. And so we'll do a divide. And the curve that we want to divide is going to be our move. And the count is going to be driven by this integer because we want both curves. Again, we'll pull this move over to here into the curve. So now we're dividing them both by the same amount, which is 24. And so it gets us close. I'm just going to hide moves because we don't need them exposed. We will keep our extrusion because we want the view of our girders there. So now we have our divisions. And let's draw a line between all of these. So we'll use the line with the two endpoints. We'll pull the points from one, the points from the second. Oh. And now we have a series of lines drawn between those division points. So that's looking pretty good. And now what I'd like to do is from that line, or from each of those lines, I want to find or determine their length. Because their length, we'll add a panel here so that we can see them. Remember, there's 24 of them. Their length will help us determine the depth for each of those rafters. And we'll manipulate this in a second. So coming out of this, I just want to be really careful. Some of this happened to me earlier, is that I want to create a number container for that length. And I don't know if I was pulling from a panel at one point in time that meant it was a string, but for now I'm sure that from that length, now I'm pulling a series of numbers. And so the next set of rules that I'd like to work with is to use an expression, and it's called a test. And so, and kind of bear with me for a second. What I want to do is kind of work through a series of these, because what we're going to do is we're going to pass this list through a set of kind of filters. So the first filter that I'd like to create, and maybe the overall logic is one that works like this, is that if the length is, so the maximum, and these are from really simple kind of span table. I have this is the disclaimer. This is not a structural design project, but one that deals more with logic. That being said, from a kind of old span table that I saw, the maximum span for a 2x12 was 225 inches. And so what I want to start with is that any value greater than 225 inches, I want to change it so that I know that it's not within the appropriate depth. And so the way that we're going to do that, and we'll work successively. So a 2 by 12, the maximum is 225. A 2 by 10 is going to be between 145 and 185. And then a 2 by 8 is going to be less than 145. And so what we're going to do is we're going to take a list and we're going to pull off the longest dimension of each one, and we're going to change the value to the list until the point where we get to the end, where this list of lengths is completely transformed into a list of depths. And then we'll use that as a way to set the depth for each of our rafters. So let's start with this, and I'll show you the kind of simple expression that we're going to use. So we'll start with our expression editor. And with this, we're going to have 3 values. So I'll zoom in and I'll add a third input. So the first, we right click, we'll change variable X to test. We'll change our second variable to A, and our third one by right clicking to B. And if we enter the expression editor, what we want to find is the if description. And the if description here lets us do something. So we find if here in the list, if we have test and we have A and B. And so this returns A if the test is true, B if the test is false. So here we have a set of things for test A and B. So let me close this and let's try and write our first rule in here for the format. And so we're going to say if, and it is case sensitive, so we want to pull this to the side. So we're going to say if test is greater than A, then that's essentially our test, comma B, otherwise test. And so that's a little abstract. It does say that there's a syntax error. So we'll work through this and we'll see we have test and we have A and B. Test is greater than A, comma B, test. So let's plug this in just because all of these are null. Let me plug in a couple values and see if they work. So incoming into this will be our number. So that's going to be our test. And what we want to do is we want to test each of these values. And I want to change the location of my second girder so that we have something that actually meets the test. But I'm going to create 2 panels as these inputs. So our first panel is going to be 225. And that's what we're testing against. So we're saying is anything on the list greater than 225? And I'll just copy that before I do. And that way, B is going to be, let's say, something small like 0.5. This will make sense in a second. The next thing I want to do is just to create, again, a number container going, well, maybe before I do, I'll copy that. Because in some instances, these are read as strings. And so 225 is going to be A, and 0.5 is going to be B. Double click into this, and now it says that there's no syntax errors. Let's create another panel and see what we get out. Actually, it's going to look exactly the same. Nothing has changed within our list. As a way to test what we're doing, let's grab one of our points and try and increase this Now we can see that in our list on the left, value 15 through 25 is greater than 225. Now on our list on the right, we can see that number 15 on the list through 25 turned into 0.5. I don't want quite that many. So I'll come back a little bit. So now our last three values are 0.5. What's nice about what we're doing is that we can drop this underneath. Let's slide this over a little bit. We'll pass the next set of values to another one of these. So let's just copy this, move it over to the right. We're going to bring the result in as the test. And this time we're going to change 225 to 185 and change the 0.5 to 11.25. Because remember, well, you don't have to remember, I'll tell you, that between 185 and 225 is an allowable depth for a 2x12. A 2x12 in dimensional lumber is 11.25 inches deep. So we can see what happened between these is that now our list that had anything between 185 and 225 has been translated into 11.25. We're just going to do this a couple more times as we work our way down to a 2x6. And so the next set of values, and we have to remember to pull the result into the test. This time 185 becomes 145. And the depth that we'll replace it with is a 2x10, which is 9.25. And now we see all the rest of the things on our list turned into 9.25, but we have a few more to go. And so I'm going to move one of my edges a little bit closer. So we have our kind of full range of the last few that are going to be, they're going to exceed the depth, but I want them to have a very small depth so that I know that something's wrong. We see the range from 11, from the 2x12, the 2x10. And let's just do this a couple more times. Bring our test list from there. Now the 145 becomes 110. And this depth will go from, what's that, a 2x10 to a 2x8, which is 7.25. And now we see that more items on this list just became 7.25. And let's copy it once more for those last bit of rafters. We'll plug that into our test. And now the 110 becomes 80. And the 2x8 becomes a 2x6, which is 5.5. So now we saw that the last bit of our numbers became 5.5. So that looks really good for us. Now let's do something, and we're almost done with this actually. Let's take these numbers, and what I'd like to do is to extrude our rafters straight down. So we'll use the extrude tool. Our base is going to be, we have to go all the way back to our lines. So let's pull this all the way over to our extrude. And what we want to do is we want to extrude in the Z direction. Using this list. I think we can plug into there, but we want to do it, we want to make this negative because we want to extrude it down. So let's see how this looks. So that looks pretty good. And what we're starting to see here is a range of values. The first 1, 2, 3, 4, 1, 2, 3, 4 are 2 by 6s. Then we move to 2 by 8s, 2 by 10s, and 2 by 12s. And then the last bit that are too long for the allowable or for the lumber that we have available for the rafters, I just had it become a small value so that I knew that I exceeded the number. And then what that'll allow me to do is to move my girders a little closer together. And so they're all there. A couple of things are happening. So if we look at the set of relationships, our first line that we're working with sits on the top of the columns. We're extruding our girder straight up in the Z direction, a certain dimension, again, a global parameter. Then we copied our top line, and now our rafters are working from the top down. So if we were to skin this roof with plywood or with a sheathing material, it would all flush out on top of the girders. And so we just set a couple of relationships with that. Now, the last thing I want to do is to use one more of our new tools that we've worked with in our, let's see, where were they? In our math operators, we've used larger than, smaller than. What I want to do this time is use equality. And the way that we're going to do this, and the reason why we're going to do this, is that we're going to set this to be, what we'll pull in is, let's see, our depth. I think we can do this with our depth. So is our number coming from the list, is that equal to something? And let's set this with a small panel. I'll copy one of these. And let's start with the 2 by 12s. So this will be 11.25. Is there anything equal to 11.25? If there is, let's see, what list are we pulling from? Our extrudes. So we're going to use a dispatch. And what dispatch will allow us to do is our dispatch pattern is going to be based on our equality rule. And let's see what this looks like with a panel. And so what the dispatch pattern looks like is analyzes each one of those, each of the items on the list coming in, is it equal to 11.25? We see that some of them are, and those will be true. This will be our dispatch pattern. Our incoming list is going to be our extrude. And let me copy 2 panels. I don't want these panels in a second, but let's just see what comes out of A as we dispatch and B as we dispatch. And what's happening is we're essentially splitting this list based on this rule for things that meet the criteria. And so we had 6. Let's zoom in. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I wasn't counting 0. So we have 7 trues. What the dispatch list gives us are the items that are true as well as the items that are false. In this instance, we don't actually want the false items. We only want list A. So what's going to come from list A is going to be our display. And we'll do a custom preview from list A. And then let's set with a color swatch what that is. Here's one more tip that I'll share with you. And that is developing a palette. And I'll just tell you, I used a really simple tool recently. And I would recommend, I know that some of you are a little color challenged, there's a website, Coolor, Coolors, that allows you to build a palette. And so we could just use this, you just hit the space bar, it generates a new palette. You can add more or less colors. I was like, okay, this looks like a pretty interesting palette. Maybe I don't want that color there. I could view shades within it. And maybe that works for us. Maybe it's not enough of a gradient. I'll hit a space bar. Maybe we just do something until we find what we like. I'm a little concerned that the lightest is too light. And so maybe we'll use something like this. I'm just going to put this on my other monitor. And let's go from, remember we started with 2x12s. So I'll use a lighter green color. Something like that. And so what should happen, and what I want to start to do, is I want to be able to see visually and instantly exactly what is happening with our colors. And so I'm going to hide all of the extrudes. I want to hide my lines as well. So I'm coming all the way back. I can hide our lines. And that should do it. So now what I'll do is I'll just copy. I don't need this panel because now you understand how that works. Let's just copy this a couple of times. So I'm going to copy it down. I'm going to change. It's the same list coming in, so these are easy things to change. We're going to go from the 2x12 to the 2x10, which is 9.25. And let's change the color. And this was going to be a little bit lighter. Maybe a little too subtle. Our 2x10 is now a 2x8, which is going to be 7.25. We'll change this color. We'll do it once more. This should be 5.5. So now we have a color range where we can start to make out visually the range of the lumber within here. And so that works well for us. Let's leave that. And what we could do now is, whether or not we want to copy those things or not, let's add another one. And let's see. See exactly how we want to copy this. Copy it down. And what I might do is just replace this first set of that group with this group. Pull it down. Now we have that there. Let's set a new line. So for our curve container, we'll set one curve. Let's lift it up. See what this looks like. And now let's lay in. Let's just work to connect a few of these things. Here's this. Let's connect our integer into our first number here, into our second number here. And we need to connect our curve or our move into our curve here. So with a pretty simple set of operations now, and with a pretty simple copy, we can see as we zoom out on our grasshopper definition, we've got what's driving our curve, our first curve, and produces the girder and the columns. We have all of this, which is the intelligence of the span of the rafters set between them. Our middle girder sits here, our last girder at the bottom, and then the set of rafters that span between those two is in the center here. So any of these things change. Remember, we have our global parameters on the side. We can change our maximum beam span, back to 144. That just changed our column spacing. Maybe our girders look a little deep. We just thin those down. Our column radius is maybe a little too thin. We just changed all of our columns. We can increase our maximum cantilever. That just manipulated the columns on the last girder. And maybe we want some more rafters, and we'll go to 16 inches instead of 24. So now you can get a sense with those global parameters, we're affecting each of the girders and the columns and the rafters and the way that all of those things are playing out. And now we can also see the range that we're getting within all of these. Maybe we want to pull this in a little bit. We can manipulate any of these if we want to start to get a range of rafter types. And we can even zoom in on the list on the bottom and start to see okay, now we're starting to get 2x12s at the lower portion. So we can change our heights of these, we can change the slope, we can change any number of things that are going on, and we can get a really simple bill of materials. We can get the lengths of all of these, and we know each of their depths. So what I'd like, if you're in the simulation and prototyping class, I'd like you to add another few bays and start to play with some roof forms and their slope and get a sense for both how the water might move over the surface as well as the lighting effects that are created through the spacing and the depth of the roof rafters. So pretty big. We covered a lot in the first portion of the tutorial in terms of setting the columns and the girders. In the second part, what we've done is we've introduced the if statement and a way to, we're not really culling this list, but what we're doing is iteratively transforming the list from the lengths into their depth. And so there was a kind of rationale for that transformation. And then what we've also set up is color coding the different depths, because again, this isn't a gradient, it's a step function. of the change in the depth of those rafters. So I hope you get a better sense of using these different types of logics to help make decisions along the way. I also hope that with this, you start to get a sense for being able to build some interactive models that give you real-time feedback. And we've talked about this in the seminar related to the notion of drawing traditionally was a simple output technique. Here, as we model, we're developing an interactive model to give us information to help us make decisions along the way. And information can also be extracted from these things. Remember, we have the heights of all the columns. That could be plugged into a database so that that could also be managed. Again, a bill of materials, other types of things that may come with this type of understanding for this type of model. So I hope the logics make sense. We can review this during class. And I hope you start using these techniques as a way to begin modeling and really thinking about the projects that you're working on. So let me know if you have questions and enjoy playing with this. Thanks.